So the last question, question 10. We're told that this curve has a stationary point when x is minus 3. And we're supposed to find the value of k, given that bit of information. Stationary point, that's code for differentiating, isn't it? Now, before we differentiate, we need to multiply out these brackets. So we've got this far in the paper without having to multiply out any kind of big sets of brackets, so it's quite nice that it finally happened. I don't mind how we do this. We could do this with a big smiley face, or we could do it with writing it out quite carefully, making sure we don't make any mistakes. It's going to look like that, isn't it? And then, having said that, we're going to do x squared plus 4x plus k minus x cubed minus 4x squared minus kx. Let's collect together our like terms. We've got minus x cubed, 1 take away 4, so that's minus 3x squared, 4 take away k, x's, and plus k. So that's what it looks like. At last, we can differentiate, which gives us minus 3x squared, minus 6x, and then this is just something times x, which goes to just the something in the end. So that's dy by dx. Now, the question told us that there was a stationary point when x is minus 3. That meant that at that point there, if x is minus 3, dy by dx is 0, because that's what a stationary point is all about. So, at x equals 3, minus 3, dy by dx is 0. So we've got minus 3 times minus 3 squared, minus 6 times minus 3 plus 4 minus k is 0. Careful with these signs. This is minus 3 times plus 9, so minus 27. But then this would be a plus 18, plus 4 minus k is 0. Which gives us, what's that, minus 27 plus 22, so minus 5, minus k 0, k must be negative 5. And there we are. And that, actually, once you got there with that, that felt like quite a nice 7 marks, didn't it? Because that was loads of marks for just doing that. Of course, if you didn't get there, it felt horrible. Then, part 2. Determine whether the stationary point is a maximum or minimum. This is all about that second derivative thing. But we now know that this k that we're talking about here is actually minus 5. So dy by dx is minus 3x squared minus 6x plus 9, because it's plus 4 minus 5. So plus 4 plus another 5. So it's that. So let's find the second derivative, d2y by dx squared. That's minus 6x take away 6. We're interested in what happens at the stationary point, which was when x equals minus 3. This is equal to minus 6 times minus 3 minus 6, which is 18, take away 6, which is plus 12. And plus 12 being bigger than 0 would tell us that we've got a minimum. And there we go. So that was that. Now it got really interesting. Given that 9x minus 9 is the equation of the tangent to the curve at the point A, find the coordinates of A. Well, this is a cubic curve. So a tangent to a cubic curve is probably going to hit the curve again. That would give us a cubic equation to solve, and I'll show you how to do that in a moment. actually this has been a question about gradient, hasn't it? Stationary point, dy by dx, nature of the turning point. It's all about gradient. And here we have a straight line with a gradient of 9. Now if it's the tangent to the curve, that means that at the point it touches, the curve must have a gradient of 9 as well. And that's our way into this question. The tangent is y equals 9x minus 9. And if that's the case, then the gradient at A, dy by dx, must be 9, because the tangent has a gradient of 9. And if dy by dx is 9, that means this thing that we just found up here, minus 3x squared minus 6x plus 9, equals 9. Well, that's another quite easy equation to solve. Quadratic equation, minus 3x squared minus 6x is 0. Let's take out that common factor of minus 3. Oh, minus 3x in fact. Sorry. We get that. So from this, oh, that would be a plus, wouldn't it? Is that alright? Common factor of minus 3x. That would give us x is 0, or x is minus 2. We have 2 points where the gradient of the curve is 9. These